Welcome to the SKF Tech and Innovation Summit 2025. I am Renato, and it's great to be your host again. Throughout my time at SKF, I've always been inspired by one question. How do we turn great engineering to real benefits? I'm talking about developments that truly help our customers and have a positive impact on the world. For example, innovations that increase reliability and efficiency, or really help reduce carbon footprint, or transform your maintenance strategies, minimize unexpected failures that deeply affect customers' operations. Last year, we focused on innovation with a purpose. Your feedback was clear. You wanted deeper discussions, clearer use case, and more real value. And this year, we're planning to do all of that and go even further. You will go from insight to impact. That means taking what we know from machines, computer simulations, and our engineers' experience and turning it into value. Think cleaner energy, more uptime, less waste, and much better decisions. In short, results that matter for your business. What you hear today is about developments from our R&D labs, factory floors, and even deep in Australian mines. Together, they show how industries across mining, rails, cements, food and beverage, and agriculture can go further, faster, and cleaner. To explore this journey, I'm joined here today by two people who are definitely leading the way. Rickard Gustafson, President and CEO of SKF, and Annika Ölme, our Chief Technology Officer and Senior Vice President. As always, it's a great pleasure to have you both with me today. Welcome.
Thank you so much. It's great to be here. I'm really excited about our event today.
Thanks a lot, Renato. It's great to be here, and I'm excited about what we're doing here today.
Yeah, we are all excited about that for sure. Well, but we also have a lot to discuss today. But let me start with you, Rickard.
Sure.
Let's start with the big picture. From your point of view, what are the big trends shaping industries right now, and how are they shifting what our customers need and expect from us?
Thanks, Renato. That is an important and a difficult question. But to me, I think it comes down to three things. Firstly, trends such as electrification, the rise of automation, and a more linear, more agile workforce will really change the way our customers need to operate.
Yeah.
Secondly, supply chains, they are moving from just in time to just in case. Resilience, localization are now key. And customers need partners that can support distributed, complex operations. And thirdly and finally, customers, they want more than efficiency. They're looking for adaptability, strategic collaboration, and long-term value. That's why we focus on solutions that simplify operations, reduce interventions, and support smarter decision-making across the entire value chain.
So thank you, Rickard. Those are indeed incredibly important shifts. Annika, building on that and even looking beyond our core industry, what emerging technologies do you see shaping how we innovate at SKF? And how do you think that you reshape what our customers expect from us in the next few years?
That's another important question. So what's exciting to me is how fast technologies outside our traditional space are actually affecting us and enable us to serve our customers better. And take advanced materials there as an example. It's opening up new possibilities for us, both in durability, but also in sustainability, and especially in extreme environments. Another one is AI, of course. Everyone is speaking about AI. It affects us. It transforms how we monitor and optimize performance in real time. But it also allows us to have shorter time to market in our own product development. Another one, if we take a look at manufacturing, mass customization, circularity, and resource efficiency, those trends, they demand intelligence embedded into the assets.
Right.
And as we do that, sensors, simulations, feedback loops become much more important. For our customers, what this really means is more predictive, more adaptive, and more integrated solutions that they expect us to offer. And we don't only have to solve the technical problems, but we need to support the broader business goals, like uptime,
We do.
like compliance, and resource efficiency.
That's so powerful. Thank you very much, Annika. So now let's connect those big trends to tangible, real solutions. Let's start by looking at the food and beverage production, where every component needs to support hygiene, uptime, and resource efficiency, all at once. And sometimes the biggest shift starts with something as small as a bearing. Jana, the stage is yours.
When your production stops, where do you look at first? And is it the right place? In food and beverage production, a bearing failure can bring an entire line to a standstill. And when that happens, the clock starts ticking. Production schedules are pushed back, raw materials might spoil, and finished goods may have to be thrown away. It's a costly interruption, and all because of a component most people never think about twice. But in an environment where hygiene, uptime, and resource efficiency all matter, the right bearing unit can make a real difference. My name is Annika Ölme, and I work closely with customers and teams across the food and beverage industry to drive cleaner, more efficient production. Water consumption, cleaning inefficiencies, and food safety risks are often tied to equipment design. And as efficiency targets rise and regulations around hygiene and sustainability become stricter, producers must find ways to clean more effectively, to protect food safety, and to cut down on waste, all without adding complexity. Let's take breweries as an example. They rely on systems like clean-in-place, bottle washers, pasteurizers, filling and capping machines, conveyors, and other automated equipment to keep their production running. These systems also need to meet strict hygiene standards and comply with food safety regulations. And that all comes with a cost in water, energy, labor, and time. Cleaning alone can consume thousands of liters of hot water every day. To put that into perspective, for every 0.5 liter bottle of beer produced, up to 0.75 liters of water may be needed just to clean the line. Bearing units on the line typically require regular greasing, but during maintenance, production, and cleaning, that grease can leak out. That means more water to remove the residue, more maintenance to reapply the grease, and a higher risk of contamination if any of it reaches the equipment, the product, or the final packaging. It's that kind of environment that we had in mind when developing the SKF food line ball bearing units. They are designed for zones where contamination risk is high, cleaning is intensive and frequent, and where downtime is measured in lost production and financial consequences. SKF food line ball bearing units are used to enable reliable rotation in the food and beverage production equipment. We've mentioned breweries, but these units are used in the production of all sorts of alcoholic and non-alcoholic beverages, as well as dairy products, meat and poultry, fruits, vegetables, and many other types of food. The hygienic geometry of the housing helps avoid dirt traps where bacteria might grow. The smooth surface enables an effective drainage and easy cleaning. Seals are positioned to block the contamination from critical areas and keep the bearing grease inside. End caps feature a patented locking system that keeps them securely in place during high-pressure washdowns. Because both the seals and the housings are blue, any loose parts can be quickly spotted and removed before they become a safety risk. Just as important, the SKF food line range complies with key global standards, including FDA and EC regulations. The bearing is fully sealed inside the unit and greased for life with a food-safe lubricant. Sealed bearings require no relubrication or maintenance, and therefore reduce the consumption of grease and grease absorbance, as well as the risk of grease reaching the final product. It's a cleaner way to operate with fewer maintenance tasks and less environmental impact. For breweries that have switched to SKF food line ball bearing units, the benefits are clear. Cleaning has become more efficient, with up to 33% less hot water needed to clean the units compared to setups that require cleaning excess grease and use non-hygienic designs. And because the bearings are fully sealed and greased for life, there's also less maintenance involved. Fewer tasks, less downtime, and more focus on production. It's a small upgrade with a measurable impact on sustainability, cleaning performance, and day-to-day operations. So we've talked about breweries, but what about your own facilities? Ever wondered how much water, energy, or CO2 you could save by just changing the bearing units you use every day? To help answer that, SKF developed an environmental cost calculator. It's a practical, data-driven tool that shows the real impact of switching to SKF food line ball bearing units. It uses your own plant conditions, cleaning frequency, water temperature, maintenance routines, to estimate your savings in water, energy, waste, and CO2 emissions. It's a simple way to turn small component changes into real, measurable sustainability gains. And it's available now at skf.com. We often think progress means big leaps, but in reality, it's small, smart changes that accumulate. Saving time, cutting waste, and improving performance day after day. And SKF food line ball bearing units reflect that kind of thinking. My name is Jana Hümmer. Thank you for your attention and enjoy the rest of the summit.
Thank you, Anna. That was quite impressive. Imagine cutting your water use by a third. If anyone ever wondered what's the big deal about a bearing, well, now you know. In the food and beverage industry, it's a 24/7 business where hygiene is absolutely make or break. The bearing suddenly becomes a strategic lever for efficiency and safety. When we cut grease contamination, we reduce cleaning efforts, avoid unnecessary waste, and lessen the environmental footprint. And that's increasingly what customers expect. Solutions that support not only the operational goals, but the environmental responsibility. Annika, what does a redesign like this tell us about how engineering has evolved, especially in tackling complex challenges like combining sustainability and performance?
Well, that's a good question. And actually, I think sustainability is performance these days. And it shows actually how engineering has evolved from optimizing components into really designing for the final outcome and with a purpose. And that's a bit different, right? It's how it moves forward. So here we are solving for hygiene, sustainability, trust in the end product as well. And it means that we have to understand the full system, the full value chain, and the customer pain points, and we need to collaborate across all of our disciplines. That's how real impact happens, actually.
Sure. Yeah, I mean, that's fantastic, but isn't that too risky to target all of that at the same time?
Well, I think it's maybe ambitious, but on the other hand, it's what expected. And we want to be a trusted partner, and we need to deliver on all these fronts, just as Annika mentioned. And customers, they ask for life cycle cost, they ask for our environmental footprint and resource impact, and we need to deliver on all these fronts. Mm-hmm. The difference today, I think, is that we have the tools, design, thinking, simulation, and co-creation capabilities to make sustainability a core part of our performance and not an afterthought.
Yeah.
And many of these gains translate directly into business value. And we can help a food producer to improve hygiene, save water and energy, and reinforce consumer trust. We move beyond just being a supplier. We become a critical partner in their operations and their sustainability journey as well.
And that's incredibly important and exciting, I think. And if you just let me add one thought, in SKF, our philosophy is actually quite simple. I mean, we fight friction. And that's why we don't just design components. we have to think in terms of workflows and people and end results. And if a solution that we provide is really intuitive to the compliance teams or to the operators, that matters to us. That means something. And more, we are designing for that entire life cycle at our customers and the full value chain, not just the part. And that's how we look at the bigger picture.
Right.
Yeah, that makes me wonder, how can we design for an entire life cycle, especially with so many variables and unknowns? Well, that's exactly where advanced simulation predictive tools come in. Let's take a closer look at SKF's digital twin technology. We've got an expert on this with us today. Michael, why don't you guide us through how digital twins are changing not just how we test performance, but how we imagine it?
Imagine some of the harshest places. At the seabed, the center of a mountain, or high up in space. In this environment, machines and their components are pushed to the limit. To protect bearing there, sealing has to be reliable. If it's not, the mission could end up in catastrophic failure. At SKF, we have spent decades improving our sealing solutions. But in truly exceptional conditions, like those in offshore application or heavy industry, even the best standard seal can reach its limit. And developing the right solution for those challenging cases, that can quickly become complex, costly, and time-consuming. My name is Michael Sensalon, and I'm responsible for research and innovation in the field of sealing products and technologies at SKF. Today, I'm excited to show you how our digital twin technology is changing the way we develop and optimize sealing solutions, making the process more efficient and more sustainable. When developing a high-performance seal, every decision counts: the design, the material, the environment it's exposed to. And today, every fraction of CO2 counts as well. Seals can generate up to 60% of the frictional torque in a bearing system and strongly contribute to the carbon footprint our customers must report and reduce to reach their net zero targets. After all, less friction means more progress. At the same time, seals are critical for system reliability, with around 20% of reported premature bearing failures caused by sealing issues. That's why sealing performance can't be an afterthought. It must be considered right from the start. Let's see how that plays out in a tough, real-world example. Think of an ocean turbine with seals 2 meters wide, operating several miles away offshore and up to 30 meters below the surface. Constant pressure, corrosive seawater, thermal gradients, all challenging the seal at once. In conditions like this, standard testing and trial and error are no options. And we must consider the impact of many different parameters early in the design phase. So how do you develop, assess, and validate sealing solution in a case like this? Imagine being able to test the effect of each parameter and predict how years of operation would influence the seal's service life, all in one instance. That's what our digital twin technology makes possible. It virtually mirrors the real seal and shows how it operates inside the actual machine. Engineers can tweak the design virtually and instantly evaluate how the seal performs under dynamic condition across combined parameters, from leakage risk to CO2 footprint and expected service life. And the virtual results reliably match the performance in the real application. It's like stepping inside the seal for virtual reality, watching it work and knowing exactly what needs to change to meet customer requirements. All before a single gram of sealing material is even produced. In standard practice, testing just one parameter like how a seal works with a certain lubricant at a given speed. It takes at least 3 samples to get reliable results. Add up the cost, and you're quickly talking tens of thousands of euros per test. There's 3 lubricants, and that's 9 seals, all of which need to be discarded, adding to the overall environmental impact. And that's not even counting the energy to run, heat, or cool the testing machine, or the effort to produce and ship the samples. That's material, energy, and CO2 spent just to find out what doesn't work. Not to mention time and effort. With the digital twin, we can explore the same variations virtually, reducing the need for physical testing without replacing it. Acting faster and smarter to help applications run longer, cleaner, and safer. But it's not just about the development process. Once the real seal is in operation, we start collecting live data. From temperature and load shift, to shaft speed, leakage risk, and more. All monitored over time with smart sensing. That feedback from field data flows into the digital twin. It helps us spot early warning signs, adjust real performance expectation, and fine-tune maintenance before problems occur. Think back to our ocean turbine example. Unplanned failures or unnecessary maintenance could mean serious cost of downtime or repair. And if a customer reports an issue, we can recreate the conditions virtually, study the cause, update the design, and often fix it before the problem happens again. It's a continuous loop of learning and improvement, from virtual seal to real seal, through development and production stages, and back again. Powered by advanced simulation, smart sensing, and data science. That's what makes our sealing solution truly intelligent. That intelligence, the insights from the digital twin, takes us beyond simply delivering a product. It enables us to support our customers with dedicated services. Because the digital twin technology gives us an unmatched understanding of how a seal behaves, backed up by over 20 years of research embedded in the platform. And while not every customer has sealing experts on site, the digital twin will help us make that expertise available wherever it's needed. Now let's think beyond the ocean turbine example. Seals are literally everywhere, in industrial robots, tractor wheels, and wind turbines. By developing digital twin technology, we can make every one of those seals smarter, more efficient, and more sustainable. Not by trial and error, but by understanding exactly what they are doing and what they will need to handle next. And that's the strength of SKF. We never look at a seal in isolation. We understand how it works together with the bearing it protects and the entire system around it. Because when you can visualize the system in this way, you can optimize the performance of every component inside it. That's how we are reimagining rotation for a better tomorrow. Thank you for your time. My name is Michael Sensalon. I wish you a wonderful day, and I hope you enjoy the rest of the webinar.
Well, thank you, Michael. If anyone ever wondered what engineering with foresight really means, I think I should show them this case.
Indeed.
Right? That's the moment engineering shifts from reactive to proactive. No guesswork, no waste, no delays, just clarity from day one. Michael, thank you for giving us such a sharp look of how digital twins are transforming seal performance in the toughest of the environments. Annika, for me, this also touches on the core of how product development is changing. How are virtual tools like digital twins reshaping the way we design and deliver at SKF?
Well, you know, all us engineers, we love to explore, design, build, test to get to the best solution. and follow a cycle of continuous improvements.
Yeah, you're right. And every iteration brings us closer to the ultimate solution.
Exactly, to where we want to go.
Yeah.
And I think this, with traditional prototyping, it works, but that process can be quite time-consuming, quite costly, resource-heavy. So digital twins are really changing the game. Speed is coming in. We're able to iterate much faster. We can simulate and refine designs virtually. And of course, that means that by the time we reach where we need to do physical testing, we are so much further and already so much closer to that final solution. So it's about learning early and succeeding in a smarter way.
You got it. And beyond speed, it's a huge leap in understanding.
Yeah.
Right? We can now explore material behavior, wear pattern, see lubricant interactions, and much more before producing in a single part.
That's amazing.
And that's a major step forward for both performance and sustainability.
Yeah, absolutely. I can just agree to that. Mike also mentioned learning from real-world data to improve future designs. How does that change the customer relationship?
Quite significant, I would say. It moves us from being a supplier to a long-term partner. If a seal fails, for example, in the field, we can now virtually recreate conditions and solve the root cause problem, often before it becomes a real problem again.
Yeah.
And that builds trust. And customers know that we are in the loop and constantly improving.
Yeah, that's right. And by the way, the simulation approach also changes the way we collaborate. I mean, we bring customers into the design process, but we also allow our customers to use our digital twins in their design process.
Mm-hmm.
And that allows us to collaborate, physically and digitally with our customers in a much more powerful way. It allows for bolder ideas, and the cost of iteration really drops, which means that we can unlock more creativity and risk-taking much earlier in the process.
Great.
And in the end, ultimately, we can bring products to market much faster and come to that customer value.
Yeah, that's great.
And speed is of essence.
It is. In the end, it's really important.
Yeah.
We've seen how virtual tools accelerate development and reduce waste, but real innovation proves itself in the field. With that said, let's head to the agriculture fields, where machines face some of the toughest conditions. Catherine has a great story to share with us today.
Nearly every meal on every table. Somewhere it began with a tractor crossing a field. But harvest is only one part of the crop cycle. Months of hard work come before it, and it all starts when large machines prepare fields the size of small towns. There are just a few short weeks for tillage. And during that period, every machine component must perform perfectly under pressure. Because in a dynamic ecosystem, there's no time for breakdown or delays. To bring food to your table, there's simply no room for failure. My name is Katrin Becker, and I've spent the past decade helping design the bearing solutions that keep agriculture in motion. Today, I will show you what happens when engineering meets real-world pressure and how it changes the industry for good. Imagine you're a farmer and tillage season has just begun. You have a week of good weather, about 1,000 hectares of land, and a narrow time frame. Every moment matters, every machine matters, and every component on that machine has to do its job reliably. Let's look at the disc harrow, for example. It's used to manage residue, loosen the soil, and perform shallow tillage. As it's pulled across the field, the rotating discs cut into the soil. At the center of each disc is a compact, sealed unit, a bearing assembly known as a hub. It's absolutely critical for reliable rotation. At SKF, we have spent decades developing and continuously improving these units, catering for various requirements of both equipment manufacturers and farmers. Today, these agri-hubs are mounted on machines around the world, helping to produce all kinds of crops. but some conditions push beyond the limits, especially when abrasive soils, high-speed equipment, and hundreds or even thousands of hectares come together. This is exactly what farmers face today in many parts of the world. The larger the fields they work, the longer the machines must run reliably. And the tougher the soil, the greater the stress placed on components like bearings and seals. These challenges are real, and they have shaped the next step in our AgriHub evolution. We focused on improving service life and durability so farmers can become more productive. Our most advanced integrated solution yet has been engineered specifically for independent tillage discs to thrive under the harshest operation conditions. This is the AgriHub T400. At its core, it's our patented super mud block seal, designed and manufactured entirely in-house by SKF. In laboratory mud slurry tests, it delivered 4 times the sealing performance of conventional solutions. 4 times, this means no unexpected downtime, even on large farms. The seal keeps performance high in the toughest conditions. With our design, there's no need for regreasing. The T400 is factory filled with the right amount of high-performance grease, and the super mud block keeps it there. And that matters because tillage is one of the most contamination-heavy operations in agriculture, a perfect storm of dust, debris, and soil abrasion. In this environment, the T400's virtually maintenance-free design keeps the machine on the field and eliminates the risk of contamination. And it's not just the seal. The T400 also features a patented outer ring with specially engineered contours that help keep soil and fiber rubs out. That's particularly important in regions with fine dust or crop residue. Combined with a new labyrinth ring, this design creates an additional barrier against contamination, where traditional hubs risk being jammed or clogged mid-operation. So what does all this mean in practice? For farmers, it means full-scale reliability with longer uptime. The performance class of each product is easily identifiable at a glance, and parts can be installed quickly. For the environment, it means cleaner fields, less waste, fewer replacements over time. With greater durability, we lower the life cycle impact of every hub we sell. The new T400 doesn't replace our AgriHub portfolio, it complements it. Our existing range with the T50 and the T100 provides excellent solutions for moderate and heavy-duty needs. The T400 is our solution for the most demanding conditions. Since every farmer has different durability needs, adaptability is key. That's why SKF AgriHubs are available as both integrated and modular designs. Modularity enables OEMs to flexibly combine different seals, bearings, shafts, and housings to match the machine size, performance class, or even the thread type their customer needs. This flexibility helps OEMs streamline their design and assembly process, especially when building machines for diverse global markets. It is especially easy since all hubs come pre-assembled with performance level clearly marked. Real plug and play, no on-site setup, no need for specialized tools. At SKF, we believe that reliable food production starts with reliable machines. And during the critical weeks of tillage, when performance is key, there is no room for failure. The T400 is our answer to that challenge. An AgriHub engineered for the scale and pressure of modern agriculture. My name is Katrin Becker. Thank you for listening.
Watching that really made me think of how much we take for granted in agriculture. Behind every meal there are farmers racing against time and weather with absolutely no margin for failure. Rickard, the world needs to produce more food with much less environmental impact, often with shrinking agricultural lands. How do we at SKF support this?
No, you're right. And when we talk about agriculture today, we're really talking about one of the biggest global challenges that we have. We have the climate change, we need food security, and with the growing population, we need to grow more with fewer resources.
Yeah.
And that's why our role at SKF is to support our customers across the entire crop cycle with solutions that are built to last, reduce downtime, and stay productive even in the toughest conditions. And we have worked with many OEMs for quite a few years, so we do understand what's at stake here.
Yeah, we do. Yeah.
And it's not just about performance. It's about helping them to deliver season after season.
And continue to do that.
You're right.
You know, that's what it's all about.
Yes.
And that's what I love about the AgriHub, actually. You know, it's smartly engineered to address the demands of enhanced durability, but also efficiency in the farm field. And farmers, they can choose from our full portfolio, and actually it will boost their productivity immediately. So that really, you know, food matters to all of us, and this has a real impact. You know, it's a solution that directly contributes to the global need for efficient and reliable food production systems.
Yeah, that's a quite nice way to put it. So let's take a moment to connect the dots. So far, we have seen how SKF is driving change on 3 different levels: clean design, predictive design, and durable design. Each one solves a specific industry need, but together they point to something bigger: engineering that delivers more value with less resources. But here's the catch. Even the most advanced technology means little if it stays isolated. If insight is locked in one machine or one department, its impact stays limited. That brings us to something we believe is critical and often underestimated: connected intelligence. How do we break silos, bring machine health into business context, and make smarter decisions with the data we already have? Well, my colleague Jonas might just have some of the answers to us.
Every day, around the world, trillions of bits of machine data are created. Vibration patterns that reveal hidden faults, micro adjustments that can improve efficiency, anomalies that warn of breakdowns days in advance. They are tucked away in silos, stored but rarely used beyond maintenance purposes. But what if we could unlock that data and use it to guide better decisions across the whole business? My name is Jonas Kemi, and over the past few years, I've been focused on helping customers get more from the data their machines produce, especially vibration data. To do exactly that, we built the SKF Observer Pi connector. It links 2 powerful systems. First, SKF Observer, our platform for real-time condition monitoring. It captures detailed machine health data like vibration and temperature and turns it into early insights. Then there's the Viva Plant Information System, one of the world's leading platforms for collecting, storing and visualizing operational data. It's widely used to support process visibility, performance and decision making. Until now, these systems weren't connected. The SKF Observer Pi connector changes that. It streams refined, high-quality vibration data directly into the Pi environment, structured, secure, and accessible across teams. The result is fewer silos, faster reactions, and better decisions across the business. Traditionally, vibration data has been used by a small group of specialists, mainly in maintenance. But when the same data is made available in a central system like the Viva Pi system, it starts to benefit others too. For example, operations team can monitor equipment health in real time to avoid disruptions. Process engineers can combine it with other parameters to improve efficiency. Data scientists can run predictive models. And sustainability teams can use it to track energy use and reduce waste. The data hasn't changed, but the impact it can have has. To put this into practice, SKF partnered with Boliden, a leading Swedish mining and metals company with operations across Scandinavia. Boliden extracts and processes essential metals like copper, zinc, gold and silver, all critical for electrification, infrastructure and industry. Their Aitik site in northern Sweden is one of Europe's largest open-pit mines. Together, we ran a pilot using the SKF Observer Pi connector to combine vibration data from critical conveyor systems with process data already available in the Aviva Pi system. So, what happened when we combined vibration and process data at Boliden? We analyzed trends from 2 critical belt conveyors, specifically looking at vibration, bearing temperature, and process signals like motor load and belt speed. That combination of data revealed patterns and anomalies that wouldn't have been obvious in isolation. We identified temperature sensors related to fire protection that were incorrectly positioned, something that could pose a serious safety risk. We saw that certain issues detected by vibrations could be handled more efficiently when the data is published in a system with a wider user community. In a critical situation, this could help save valuable time. We also uncovered issues with lubrication intervals by combining vibration and temperature data. By rethinking these intervals, Boliden can avoid costly and potentially dangerous motor failures. None of these came from adding new hardware. They came from looking differently at the data they already had. Now let's step back. What does this mean for sustainability? First, fewer breakdowns mean less emergency repair work and production interruptions. Second, targeted maintenance extends component life and reduces unnecessary part replacement. And third, by seeing how machines behave in real conditions, we help cut excess energy use and improve process stability. These are quiet gains, made not through big investment, but smarter data use. So, how does all this work behind the scenes? At the core is the SKF Observer Pi connector, developed by Dianomic using their software FogLamp. FogLamp is based on a secure, open-source framework and acts as a trusted bridge between SKF condition monitoring system and the customer historian, such as the Aviva Pi system. The connector safely transfers refined vibration data into this environment and works seamlessly across on-premise, cloud, or hybrid setups. In the next step, we use the Aviva Connect cloud platform to share Boliden operational data, including vibration data, with SKF. What's really important here is that Aviva Connect puts the customer in control over what is shared and where the data goes. For many years, condition monitoring was seen as a specialist activity, something handled by a few experts using dedicated tools. But with the SKF Observer Pi connector, that mindset is changing. When vibration data becomes part of a shared central platform, it stops being just a maintenance tool and becomes a strategic resource. Now it can support operational planning, efficiency goals, safety decisions, and sustainability targets. What makes the SKF Observer Pi connector so powerful is that it's not limited to one customer, one mine, or one industry. It can work just as well in a pulp and paper mill, a rail depot, a marine engine room, or a wind turbine. Why? Because many industrial organizations already use historians, and the connector integrates directly into those environments. No need to install a new platform. No need to restructure your data strategy. Just unlock the insights from your existing SKF systems, make them available wherever they needed. At SKF, we spent decades helping machines run more reliable. Now we're helping businesses run more intelligently by turning machine health insights into strategic tools. They already have the data. What's new is how accessible, visible and actionable that data can become across teams, sites and systems. My name is Jonas Kemi. Thank you for your time and for being part of this journey.
That was a really interesting presentation about this new digital solution. I think it's actually quite
I think it's good. It's quite interesting that they are doing that.
It's kind of amazing how much impact we actually do with our products.
And we couldn't do that before, so that's amazing.
Yeah. We've just been discussing that already. It's quite a statement, wasn't it? No new sensors, no added hardware, just new visibility. Annika, digitalization is evolving quite fast, and while AI gets most of the spotlight, the real value seems to come from how well digital solutions fit into real operations. What do you see as the key enablers that make these solutions actually work on the ground?
No, I think you're right, Renato. Digitalization and AI are both important. And that's the whole point. It's about making technology usable in real industrial environments.
You're right.
And that requires many technologies. I mean, today, companies are not short on data. I mean, I know we are not. I mean, companies are drowning in data. That's not the issue. What every company needs now is clarity.
Yeah. The structure.
And exactly. And, it's not just knowing why or that a machine is vibrating. It's understanding the root cause. It's predicting the future as a result of that. And this needs to be done in the context of the production process, of the product quality, of how much energy it uses. Right. So it's a lot of data that needs to be transformed into knowledge. This particular solution uses FogLamp. It's an open industrial IoT technology, and it's really put structured data at the edge. And then it integrates into the Aviva plant information system, providing access to that historical data that we do have. So instead of isolated diagnostics, it really gives a holistic view of the performance. And because it's a no-code solution, that means that it's fast to deploy, it's easy to scale and adapt. And that matters because that's, again, saves time, right?
That's huge.
And ultimately, it's about making those systems speak to each other with the right data so that teams can make smarter decisions faster.
Yeah, you're right.
Yeah. Oh, that's very good, Annika. Thank you. But that case, it even touches on something broader. Yeah. Like it's how companies collaborate, both internally and really across their different ecosystems. So, Rickard, what's your take on it?
Now, many of our customers, they ask this question themselves. It's a key thing for them. How do you modernize operations without starting from scratch? The answer is smart evolution. You don't replace everything. You connect what you have and make it work better.
Yeah.
And when the teams across functions share the same insights, magic happens. You have collaboration. You get decisions faster. And transformation scales all of a sudden across the entire value chain.
Yeah, I think you're right. And I mean, let's not forget that integration is a multiplier. And really, you might improve your maintenance planning in this case, but suddenly you're also reducing waste.
You're right.
There's an impact on extending the asset life as such, which is crucially important and impactful, and also improving the reporting. So, it has a lot of different effects.
Yeah. No, I need to say I love this concept of multiplier. I mean, that's a very powerful idea. And it's not just digital. When smart design meets real-world pressure, the right solution can multiply uptime and flexibility at the same time. Well, but now if conveyor pulleys are part of your operations, this next story is for you. It started in Australia and it's now making an impact around the whole world. Henrik, over to you.
Some of the toughest engineering challenges begin far from any lab. They start in the field, where machines never rest. And sometimes they start in the dust, heat, and relentless pressure of a mining site in the Australian outback. There, conveyor systems stretch for kilometers, carrying thousands of tons of raw material every hour, day and night. When one of these systems stops, it could mean losing millions of dollars. Could we prevent that? A simple question that demanded everything from our engineering team. I'm Henrik Saleback. and I spent the past 20 years helping SKF develop roller bearing solutions for some of the world's most demanding applications. Today, I'll show you how we changed the way bulk material is handled worldwide, and it all starts in the mining industry. In mining, conveyor systems are the lifeline of everything. If they stop, everything downstream stops too. Crushing, loading, transport, even production targets. These conveyor pulleys are often placed in remote locations, exposed to demanding environmental conditions and heavy vibration. In many cases, they are meant to run for 11 months straight before a major repair stop is planned, but in reality, they often fail much earlier. Some companies have to stop production every few weeks because extremely aggressive, abrasive aggregates force themselves through conveyor belt seals, bringing pulleys to a sudden halt. Replacing bearings, reinforcing seals, this all costs valuable time. That's the challenge mining companies around the world face today, among them one from Australia. Their pulley systems were operating under extreme load and environmental stress, and traditional housing solutions were simply being pushed beyond their limits. So they turned to us to help them. We faced an engineering problem. The specialized taconite sealing system used in these environments consists of multiple components, like labyrinth rings, grease chambers, a guide ring, and protective end plates. This setup takes up significant space. To accommodate all these components, OEMs had to extend shaft lengths, particularly on wider pulleys. But longer shafts bend more under load. That bending causes belt to drift out of alignment, and that's when you risk a complete system shutdown. Customer faced an impossible choice: a high-performance seal that requires a large housing or a simpler seal not designed for these harsh environments. But what if we could design a more compact solution that was also easier to install, provided better protection, and lasted longer in real mining conditions? Working with our engineering teams in Australia, we developed an entirely new pulley housing equipped with an improved cutting-edge seal. Especially designed for this unique application, the entire assembly is compact on the outside and powerful on the inside. This customized conveyor pulley bearing housing started as a solution for one mine, but its concept is already changing the standard for many. The patented seal design has been optimized to handle fine, abrasive dust with minimal grease supply while minimizing the overall width. But what truly makes the difference is that it's nearly impossible to install incorrectly. You position it, you line it, and it locks in place. The result? Long-term protection without constant regreasing, high performance, less downtime, and less waste. We designed the house with a bolt-on end cover so inspection and grease sampling can happen without disassembling the pulley. And we made it ready for condition monitoring. Sensors can be added directly, giving operators early warnings before problems occur. Companies around the world can now trust their conveyor pulleys to work reliably throughout the year. Faster installation, longer service intervals with simplified maintenance, and reliability in performance. For OEMs, less required space means greater design versatility. They can develop solutions using less material and without making compromises. This housing solution began as a focused project in the Australian mining sector. Now, it's being adopted globally. Over 5,000 units have already been delivered, not just to mines, but to ports, cement plants, mineral processing facilities, and more. Because wherever bulk material needs to move reliably, the same questions apply. Can we install these plumber block housings easily? Can we trust them long term? And can we even reduce our environmental footprint while doing it? Let's not forget, in these industries, reducing maintenance is about more than costs, it's about impact. Less contamination and less regreasing mean longer component life, and that means less replacements. The SKF conveyor pulley housing for high performance is one example of how engineering and sustainability can move in the same direction. When we started this journey, we were standing in the dust and heat of the Australian outback, watching conveyor systems that couldn't afford to fail. This is what makes SKF's approach to innovation special. We start where the rubber meets the road, or in this case, where the bearing meets the pulley in the harshest conditions on Earth. Our goal is to not just reduce friction, but to actively fight it, to achieve more with less. This only works because we listen to our customers' most pressing challenges, and because we can combine global expertise with local insights. When you consider the scale of need out there, we can make a tremendous impact. And it all started far from any lab, in the field, where machines never rest. My name is Henrik Salebakk. Thank you for watching.
Well, thanks, Henrik. What a great case.
Indeed.
Actually, we see similar stories in many other times, where a solution for one critical application then quickly proves to be valuable in other areas.
Yeah.
And when we tackle tough engineering problems, we do it with scalability in mind. We have to, because reliability, efficiency, and fighting friction are universal needs.
I mean, that's true. And I think, Henrik shows a great example of how we deliver technologies proven in the toughest environments and scale them from field tests to really global adoption. And they're scalable and they deliver lasting value as well. And that's how we had to use our resources in the correct way.
Yeah.
And we designed for that. But the momentum really builds when we co-develop with customers and partners. That's when the magic happens.
Yeah. That's kind of the secret sauce of SKF, and that's especially relevant when we interact with our OEMs.
Yeah.
They operate in multiple markets, right? They facing different conditions, but often the same core needs. Reduce complexity, being one, shorten development cycles, and meeting tough sustainability targets.
Yeah.
That's where modular, scalable systems come in. They give our customers the flexibility to adapt without reinventing every single time.
Yeah, that's right.
Well, thank you, Rickard. Thank you, Annika. What a powerful set of examples we've seen so far, really demonstrating how we move from deep understanding to tangible, impactful results. As we enter the final chapter of today's summit, we turn to modern rail, to a story that brings together many things we have explored so far. Precision, partnership, and the power of rethinking what's so often overlooked. This is a solution designed from scratch, developed in close collaboration, engineered using digital tools. And now it may turn public transport into a massive energy saver for entire cities. Over to you, Ian.
We like to think wasted energy comes with signs. Something overheats, something smokes, something grinds. But some of the most persistent losses are hidden in the plain sight. Take bearings in metro wheels, for example. Tiny components in operation that quietly generate friction, and with it energy loss. Now suppose we could optimize just this one component in the way that significantly reduces friction. What might seem like a small tweak could contribute to a savings that really make a difference. My name is Jan Babka, and I have spent over 2 decades at SKF working on wheelset bearing solutions for the rail industry. Today I am excited to share a pilot project that shows what's possible when we challenge the standard, a low-friction taper roller bearing unit that brings rail transport closer than ever to real energy efficiency. The unit is the first outcome of our rail friction program and part of the broader goal, a new low-friction platform for the 2 most common railway bearing types, tapered bearing units and cylindrical roller units. It's a project that couldn't be more timely. Energy demand keeps rising, and at the same time, the need to cut consumption is more urgent than ever. Across industries, there is a growing pressure to operate more sustainably and cut energy waste. And in the rail transport, many of the obvious levers have already been pulled. Lighter materials, improved aerodynamics, more efficient onboard systems like air conditioning. But there is still untapped potential in components that usually go unnoticed. Metro trains make this potential very clear. In many cities, they run constantly, day and night, every day of the week. Picture one moving through the underground, 10 coaches long, each riding on 8 bearings. That could be 80 bearings on a single train, all in motion, all generating friction every kilometer it travels. Now multiply that across a full fleet, dozens, maybe hundreds of trains running non-stop. Suddenly, what seems like a small component becomes a significant energy factor. In fact, a thesis by the University of Graz showed that in one example of a railway vehicle, wheel set bearings alone accounted for around 7% of total vehicle resistances. That's when we committed to going further. And when Siemens Mobility came to us with a request from a metro operator to reduce energy consumption, it felt like the perfect starting point. But turning that ambition into action wasn't simple. For components hidden inside the axle box, there was no standard way to measure a friction torque. So we developed our own test method, reliable and built around the real operation conditions. In parallel, we created a digital twin model of the bearing's friction behavior, which Siemens Mobility integrated into a full virtual model of the vehicle. This made it possible to simulate energy use under real driving conditions and optimize key components before the first train was even built, a valuable contribution to a much bigger picture. Building on these insights from tests and simulation, we moved from the virtual world to the real world design and created something completely new. Not by adjusting a few parts, but by rethinking the entire system from the ground up. We reshaped the rollers to optimize the macrogeometry. Then we refined the microgeometry, including the raceway profile and flange contact, and we designed a new cage. Together, these changes define a new generation of wheelset bearings. And the improvements speak for themselves. By modifying the microgeometry and making the rollers shorter and thicker, we reduced friction where it matters most, inside the bearing. This also enabled the new cage design, providing better guidance and greater stability for the rolling elements. And a small shift in macrogeometry seen in roll shape is even part of a patented SKF design. Once we had the final bearing design in place, it became a part of a bigger picture. If just 25% of metro coaches worldwide use this bearing system, about 40 gigawatt hours of energy could be saved each year, the equivalent of powering around 10,000 homes with electricity for 1 year. With the new low-friction tapered roller bearing design, reducing friction was the key focus. But the single adjustment also brings a range of other benefits our customers often ask for, including higher speeds and longer service intervals. Lower friction means better lubrication conditions and reduced wear, creating the potential for longer maintenance intervals. That translates into more uptime, fewer service windows, and better use of every train in the fleet. And the impact reaches the people behind the system too, like those driving the trains every day, who may benefit from more stable schedules and fewer last-minute changes. The collaboration with Siemens Mobility marked an important step, one that reflects the needs of transport operators worldwide, and they likely won't be the last. This low-friction bearing concept can be used in every railway vehicles, but the potential for this bearing design, for example, in urban rail is huge. More and more people are choosing public transport, not just for convenience, but because it's more sustainable choice. Across the rail sector, the market is seeing steady growth, around 3.5% per year. That development is now opening the door to further applications, with additional sizes and use cases currently being explored. Because wherever reliability, energy efficiency, and smarter maintenance matter, this technology has a place. But what really made this project work was the team behind it. People from across the value chain, spanning 6 countries, came together to make it happen. Design, testing, digital tools, field experience, every contribution shaped the result. It became more than a technical achievement, and we are proud to say it was recognized with the Purpose Award 2025. And while this project started in the world of urban transport, the questions it raises apply far beyond railway vehicles. Where in your industry could smarter bearing system reduce friction and unlock better performance? We believe the insights from this project can be applied across the sectors, systems, and challenges, because at SKF we are driven by a clear mission to fight friction and move the world. My name is Jan Babka, and thank you for listening.
There's something bold in this story. It takes an entirely new direction. While many innovations extend the life of current systems, this project introduces a fresh design with friction reduction as a primary objective from day one. Annika, to me that goes a lot beyond the technical upgrades. What stands out to you?
No, and that's what it's all about, how do we take our products into the next frontier? But I love the mindset behind this work, actually. I have to say that the team really reimagined everything. And that's very interesting to see, the geometry, the internal mechanics of the product, but also even how friction is measured and modeled. And that's a big step. It takes a lot of courage to do this. That's clear.
Yeah.
And it reflects on the willingness to rethink the fundamentals, not just on the edges.
Yeah. Rickard, with rising passenger volumes, stricter sustainability targets, and pressure to reduce life cycle costs, how do you see solutions like this shaping the future of rail?
No, you're right. The industry is under pressure and need to deliver more capacity, longer maintenance intervals, and higher sustainability, while using fewer resources. Operators, they need solutions that reduce energy consumption and improve their environmental impact without compromising with reliability, which is absolutely key.
No, that's right.
Solutions like this help make this possible. They reduce friction, improve efficiency, and support smarter fleet planning. And in the end, it's about enabling smarter, cleaner, and more efficient mobility at scale.
Yeah, it's pretty exciting.
Yeah, it is.
And what excites me in this is that we are no longer just solving for one part. It's actually, shaping the entire system performance.
Right.
And that matters to us and to our customers. And maintenance becomes more predictable, uptime is much more strategic, and energy use is much more transparent than it has ever been. So in fact, rail operators are really rethinking everything, to your point. I mean, it's about fleet configuration and procurement strategies, maintenance intervals. And this is a clear example of how specific technology and engineering advancements and efforts in bearing design can actually lead to measurable decarbonization, but also operational cost savings.
Yeah, indeed, Annika, it makes a lot of sense to me. So far I had 6 stories today. Each of them showed a different path, but together they form a map of where industry is heading. With everything we heard so far, let's now take some time to envision the months and years to come. Annika, Rickard, now looking ahead, how do these innovations and our theme from insight to impact position SKF for the future, making sure we are competitive in this rapidly changing industrial world?
Yeah. I mean, for me, it's about being a truly indispensable partner, to our customers and in some cases to our suppliers as well. And, we need to be that company that really understands the intersection between technology, sustainability, and the operational demands and the real life of our customers. And if you look at this, we combine the cutting edge R&D, that we have been talking a lot about today, with deep application knowledge really out there in the field. And this combination turns into that measurable value that we are all looking for and that our customers are looking for.
Yeah.
So, whether it's digital twins or energy efficient products, or if it's, integrated data solutions, it all goes in that direction. And that's where we stand out. And that's exciting. And that's why, it's a joy to be here today. We help our customers to make better decisions in the end. And that matters.
Yeah, totally.
In a fast changing world, we are reshaping the future of reliable rotation.
That's a powerful statement. And I truly agree. From insight to impact means that we're focused on solving our customers' challenges, even the ones that we haven't yet fully defined. Our competitiveness comes from the value we create through complete solutions and strong partnerships. We cannot do this alone.
No, we cannot.
We need partnerships. And we do it with a clear view of the global trends, such as electrification, decarbonization, and general sustainability. It's all about measurable progress, more uptime, smart production, and lower impact. We help build more productive and sustainable world, where we can all achieve more with less. That's how we stay relevant and valuable in transforming the industrial world.
Yeah, that's right.
That's a fantastic vision for the future and a perfect way to close out our fireside chat. Annika, Rickard, thank you both for these truly insightful discussions. That was really good.
Thank you.
It's clear that from insight to impact isn't just a theme. It's really deeply embedded in how SKF innovates and delivers value. And to all of you watching, thank you for joining us. We hope today gave you new ideas, new perspectives, and a better understanding of what's possible. If you'd like to learn more, speak with our experts, or revisit any part of today's summit, just visit the SKF Tech Innovation Summit on skf.com. There, you'll find all the presentations, contact details, and next steps. Thanks again for joining us, and we look forward to continue this conversation. Until next time.